Welcome to Math 2318. This is section 5.2. In this section, we're looking for the characteristic polynomial and the eigenvalues of a matrix. So here we have matrix A, which is 2 by 2, 6, 4, 4, 6. We have lambda I, which has lambda down the diagonals. So we form the determinant of A minus lambda I. All right, so that's pretty easy to form. The determinant, we multiply down and subtract the 16. And so we get 36 minus 12 lambda plus lambda squared minus 16. Cleaning that up and setting it equal to 0, that is our characteristic polynomial. It is factorable. It's factorable into lambda minus 10, lambda minus 2. Setting each of those pieces equal to 0, we get our eigenvalues of 10 and 2. All right, so we repeat this for question 2, a new A. So here's matrix A. So I form the determinant of A minus lambda I. So again, the determinant is the downward diagonal minus the upward. So the upward, I've got a negative times a negative, which is a positive. So I'm subtracting 8. We multiply this out and clean it up, giving us the characteristic polynomial. We just need to solve this to figure out what are the eigenvalues. It doesn't factor, but we can use the quadratic formula. So minus b plus or minus the b term squared minus 4ac. All right, so I get 100 minus 32, which is 68. 68 is writable, so 68 is writable as 4 times 17. Square root of 4 gives me the 2, and then split it up. 10 over 2 is 5. The 2 over 2 cancels, and so I get 5 plus or minus the square root of 17. All right, we repeat this again for question 3. So here is A. I form the determinant of A minus lambda I again. All right, the only tricky part is all the negatives everywhere. So cleaning that up, we get our characteristic polynomial. So there it is. Not factorable, so we use the quadratic formula. And so looking at the quadratic formula, I see we get a negative under the radical, and so I get complex eigenvalues. So there are our complex eigenvalues. And finally, in question 4, we have here is our matrix A. I form the determinant of A minus lambda I. So it's a 3 by 3 determinant. There's no real easy way to pick a row or column to expand by. So I'm going to pick to expand by just the top row. So minus lambda times this 2 by 2 cofactor. Remember, this goes plus minus plus, so minus 1 times this cofactor plus 2 times this last one. So just a question of cleaning this thing up, and what we end up with is a cubic polynomial to be solved to figure out what the eigenvalues are. Now, they didn't ask us to solve it, but I went ahead and did it just to show you to get the approximate values. And I did this using Wolfram Alpha, multiplied through by -1 and solving. And so we get the approximate eigenvalues. They are real numbers 2 negatives and 1 positive.